Welcome. So this is the fourth and final video on the sequence and series segment. If you're just joining us now, I would advise you to go to the first video where they all have the same title. The only difference is I put part 1 as an attachment, part 2, part 3, and part 4 to each videos. Again, if you do not need to watch the first 3 and this is all you want, welcome. If not, please watch the first 3 because in this video I'm just going to go directly into the assumption that you understand the concepts behind my solution. So if the things that I'm doing sounds vague, it means you have not watched the first 3 videos. Again, go to the pre-calculus playlist. You can see all 3 videos there. Alright, so let's continue. So the first question says you should find the sum of the finite arithmetic sequence. The sum. So what are they really asking us here? Let's think about this. Are they saying add them up? 1 plus -3 plus -5 plus -7 plus -9? Yeah, it's really that easy. This is a finite arithmetic sequence where each term you get by subtracting -2. Now they're telling us find the arithmetic sequence, the sum, the total sum of it. We can easily do this just by adding it, but that's not what they really want us to do. They want us. You can do that because there's only 5 elements. In a case where you have like 100 elements, you can't really do. You don't have time for that. It's not efficient. There's a better way to do it when you have a lot of elements. So I'm going to show you the formula to use in a scenario when you have more than 5 elements, unlike the one that we have here, where it's only 5 elements. Here we see that here you're adding -2. You're adding 2. -5 plus 2, -3. Common difference is 2. Here the common difference is -2. Alright, so pause the video, attempt it yourself. Should take you 5 seconds the most, just to add them up. Play the video to see. Now let's move on. So I'm only showing you the solution to the first one because it's the same concept. Showing the solution to this one. So the solution that is on the next that I'm about to show you, it's only for this one because I believe you can do the same thing using the summation by yourself. Once you use the summation, post your solution for number 2 on the comment section. I really appreciate your feedback. Thank you. Alright, so here we go. So here's the formula to use when you're finding finite arithmetic sum. Not geometric, finite arithmetic sum. So here's the formula. Here's the generic formula right here. Write this down somewhere in the book. I didn't give this to you earlier, so put this down somewhere. So this is the term. So these are the terms they give us. Now, if the sequence is arithmetic, no matter how big it is, it can be 1 million terms. It doesn't matter, as long as it's arithmetic, and they told us that, and we can obviously see that you can find the sum of everything using this formula, and is the last element, basically is the total amount. So let's see what the total amount is here. Here we have 1, 2, 3, 4, 5. So 5 elements. So n is the total number of elements. So there's 5 elements. So you plug in n for 5 right here. Put in 5 here. A1, we know A1. That's right here. What is A of 5? Because remember, we're plugging in n for 5. So what's A of 5? That's the last element right here. Plug it in, and you get -25. Very simple. As long as you know the first and the last of the finite arithmetic sequence, you can find the sum. So here's the more challenging question. Well, it's not really challenging, it's just a word problem. Most students hate word problems. So I put one here that would really test your understanding. So take a look at this one. Try to solve it before you go on to the next problem set. I think it will be very helpful for you guys. A county fair is holding a baked goods competition in which the top 8 bakers receive cash prizes. First place receives a cash prize of 200, then 175, then 150, and so on. Write a sequence A of n that represents the cash prize awarded in terms of the place in which the baked good places. That's a typo there. In terms of the place n, in which the baked good places. If that makes any sense, yes. Basically, they're saying write a sequence A of n. Find the formula A of n. That's what they're saying. Then here, find the total sum. Total amount. We just did that in the last problem. We used this formula. So that's a hint. Here, you're looking for A of n. Why do we need A of n? Because we need to find what? Right here. We need to find this part here, the last term. So that's why we need A of n. So pause the video, try this out. Once you solve it, play it to see the solution. So here's my solution. So the things that I did is I put all the prices out. I labeled them in terms of their notation. The first element is 200. Second is 175. Third price is $150. Obviously, you can see the pattern. It goes down by what? $25. So this is an arithmetic sequence where the common difference is minus 25. D is minus 25. So going back to the formula that I showed you in video number 1, I'm not going to write this formula back. If you don't know it, go back to video 1 to go watch it. So A of n equals A of 1, the first one, n minus 1, and then D. What is D? D is the difference. Minus 25 in each cases. Minus 25. 200 minus 25 minus 25. So that's A of n. Very simple. That's all they want. They want the formula for this. All we're doing is using the formula that's given to us. The second thing says find the sum, the summation. Again, the sum is very simple. Using the formula that I gave you in the last question, go back to the video to get the formula S of n. The formula says here is n over 2. N is the total elements. How do I know there's 8 elements? That's a good question. How do I know? How do I know that there is 8 elements? So the way I knew this is I easily went down by 25 each time from 200 to 175, then to 150, then to 125, and then to 100. So I went all the way down till I got to the last one, and then I realized that, oh, that's it, that there's only 8 elements in it. Obviously, I mean, it's a cash prize. If you read the problems, you can also look at the problem and they'll tell you that there's 8. If you don't want to do it my gruesome way, read the problem. It says 8 bakers. 8 bakers received the cash prize. So right away I knew that there was 8. So that's an easy way to do that. So we're looking, so total elements is 8. The first element is 200. The last element is $25. Plugged it in, used my calculator, bada boom. I got $900. So that's the sum. Again, this is really simple. Use the formulas to plug each numbers in. If this problem seems confusing to you, let me know. Leave a comment. And feedback's always good. Here's the final one. So the final question in the final video of my sequence segment. I really hope you guys enjoy. For those of you that have stayed with me from video number 1 and through video number 4, I want to say thank you. Hope you've learned something. And if you have any type of question, leave a comment, feedback, and I'll get back to you. Here it says, find the sum of the finite geometric sequence. And the second one says, find the sum of the infinite geometric sequence. So again, this is really, really simple. We're just doing formulas here again as well. Obviously, you do not want to do, let's look at the first one first. You do not want to plug in 0 here, and then 1, and then 2, and then 3, all the way till you get to 50. That is tedious. That is not how to solve this problem. It's a waste of time, your time and my time. There is a more efficient way to find the sums of geometric sequence. Now, I have not given the formula to this here. So if you already know it, this is good. Try it out yourself before you go into to watch the solution. Here as well, find the sum of the infinite geometric sequence. Also, there's a little thing with this one. When R, I'm going to explain. When R is less than 1 and greater than -1, R, by the way, is the ratio, the common ratio between each term. When R is greater than -1 and less than 1, then there exists a formula that you can use. If R doesn't fall in between this cannot be solved. So if the question is what is R? Think about it. Wink, wink. What is R? Think about it. I'm sure you can guess what R is. Very simple. So if R falls in between that, a formula exists that you can use to find an infinite. Remember, as I underlined this, only for infinite this rule applies. If R falls in between -1 and 1, you can use a formula to find the sum. If R does not fall in between, you cannot use one. Now, when we get to, we can prove this, but this is not the whole goal of this video. So pause the video, try to find this out, and once you're done, play the video to see the solution. So I'm going to show you the solution to the first one first, and then the second one. So here's the formula that you use for the finite sum. So for the finite sum, finite geometric sequence, this is the formula. So write this down somewhere. This is the formula for the finite geometric sum. Not the infinite, the finite geometric sum. Again, you take the first element, A1, which is 30/2. You take R, 2/3, and just plug it in. And let your calculator do the magic for you. How do I know what R is from here? Some of you may ask me, so well, how do you know what R is? Well, right here. R is a term. You get used to seeing this. This is not an obvious way of doing it. One way of actually doing this is plug in 0. Plug in 0 here, and tell me the number you get here. Then plug in 1. So then you put a plus. Then you plug in 1 here. Plug in 1. Then tell me the number you get here. Then plug in 2 here. Then tell me the number you get here. When you do all of this, like do it for the first 5, you can obviously see what R is. And then eventually you know that R is 2/3. But once you've done enough practice, you can pick out right away from the problem what R is just by looking at the problem. It stands out to you in geometric sequences. So let's see the solution. So we know what R is right here. We have A1. I plugged it in. That's how I got A1, by the way. I plugged in n equals 0. I solved it. So how do I know n is 50? Let's go back. It says find the sum of the geometric sequence. The last number is what? 50. So I'm looking for S of 50. And how do I know what A1 is? First element. How do I get the first element? First element is when n is, well, technically the first element is when n is 0. So you put 0 here. You put 0 here. And then you solve for it. And then according to what I did, you get 30/2. So this should be A of 0, not A of 1. My apologies for this. A of 0, you get 30/2, which is 15. Now, the formula says A of 1, the first element. The first element in this case is A of 0. So don't get confused with the sub numbers. They're the same thing. Here, A of 1 just means the first element. The first element. In this case, the first element just happens to be A of 0. That's why. So you plug that in here. We know R. You plug that in. And that's it. And n is 50. And this is what you get, 44.99. So let's do this. Take a look at the solution. Again, it's pretty simple. Once you know R and you know the first element, the calculator does the rest for you. Next one, find the sum of the infinite geometric sequence. So we need to know what R is here, obviously. And just by the look of things from practice, again, you can find R right here. And R falls between this rule that I said. So R is -12. If it falls between these boundaries, so this is the formula for infinite. Write this down somewhere, please. Save this. This is the formula for infinite series. And then again, all you need to know is the first element. How do you get the first element? Well, n starts from 0. Plug in 0, you get 1. So that's the first element. We know r, plug it in. So when r is negative half. So when you put negative half here, it becomes 1 plus half, which is 3/2. You flip it, and you get 2/3. Again, I know the questions got a little harder at the end, but this is how you become better at this, by problem solving. If you have any questions, any type of clarification that you want me to show you, to explain, please let me know. Leave a comment, leave a feedback. If this is your first time watching my videos, please subscribe. Thank you, and have a good one.